In this demo, I'll introduce Logan, an LLM-powered log analytics tool with causal inferencing. Logan extracts valuable insights from logs using BERTOPS, a large language model specifically designed for log analysis. A key feature of Logan is its ability to perform inference using only a CPU. That is, no GPU is required for its operation. Now, I'll walk through a demonstration showcasing the various insights Logan can generate from a given lockdown. To run this tool, the user needs to provide a set of log files which are required for analysis. In this demo, I'll upload a single file, but the tool also supports multiple file upload. Once the upload is complete, the UI displays a preview of the log data along with its key statistics such as number of log lines, file size, and count of unique tokens. As you can see here, log data is huge, almost 500,000 log lines, but it has a lot of repetition. The structure of the logline remains the same with only variables that keeps on changing. We leverage this repetitive nature to optimize the way we run LLMs on log data in real time using only a CPU. To begin processing, users can simply click the Process Data button. The first view provided by Logan is the Data Summary view. It provides a microscopic view by presenting only the unique log lines present in the data dump. As you can see, the total number of log lines that exist in this data dump are 43. So out of 426k log lines, 43 unique log lines exist, and that's a reduction of almost 99.9%. Users can go through this data and understand the potential issues that may exist in the application. Data Summary view shows unique set of log lines with their corresponding key entities, golden signal, and fault categories. All the highlighted phrases in this table are the key entities that were extracted by a LLM developed for logs called BERTOPS. Users can quickly review the data and filter them based on golden signal. For example, latency means something timed out. For example, here some operation or the session timed out. Similarly, if you filter it by availability related issue, then Logan will show you the log lines corresponding to something which was not available. For example, a session type was not found, or the session ID does not exist, etc. The next view is the temporal view. It shows the distribution of golden signal grouped by a time window. Here the time window is set to be 1 hour. This view allows the user to track the progression of fault. For example, we can check if an availability issue led to a latency issue and eventually an erroneous event occurred. When you click on any one bar of the temporal view, Logan presents the set of log lines that belong to that particular window. Here, the logs are temporarily sorted and user can use this table to do pre-fault or post-fault event analysis. They can also filter log based on golden signal, or they can sort the log lines by timestamp. Also, they can do a keyword-based search on this data. For example, we can filter logs based on an exception code, or we can get logs belonging to a particular session ID. For example, if I take this session ID, then we can see the log lines which led to the occurrence of the event. The next view we have is the causal graph view. This view mines the causal relationship from the data and presents it in the form of a graph. The node color here represents the golden signals and the color scheme is same as other view. The directed graph has a cause-effect relationship. For example, in the node 24, which is an error, causes node 27, which corresponds to a latency issue. This view allows SREs to find potential root causes of an issue. Let's consider the biggest graph. And the root node here, 29, of the graph may be the main culprit. On hovering over the nodes, we can see the logline event that represents the node along with the key entities highlighted. The final view that this tool generates is the causal summary view. It summarizes the causal graphs mined from the log data dump. Logan uses IBM's Granite models to generate summary of the graph. All the insights extracted earlier, for example from golden signal, fault categories, key entities, causal graphs, their associated log events, all of them are passed to the model as prompt, and then this information is summarized in the causal summary view. For example, here the summary of the above graph says that the service instance failure led to session aborts and high latency, which may be the root causes of this potential lockdown. Here are the key takeaways of Logan. It is interactive, efficient, and versatile.